All right, for 6.1, working with properties of exponents. Okay. Here are a couple of properties of exponents that you want to get very familiar with. You'll be using these often. If you don't understand any of these, please make sure to ask for help. All right, so going over example 1, evaluate each expression. 6.7 to the 0th power. Anything to the 0th power is equal to 1. That's all there is to it. Done. Now here we have -2 raised to the -4th power. All right, when you raise something to a negative power, you switch its position. Right now it's in the numerator position, but we're going to put it in the denominator position. And when you do that, the exponent becomes positive. All right. So now I have 1 over, and -2 to the 4th power, -2 times -2 times -2 times -2 is 16. There we go, done with that. On to the next. All right, simplify this expression, write your answer using only positive exponents. So they don't want any negative exponents in the solution. All right, so here I have 4. X to the 0th power is the same thing as 1. Then I have y to the -3rd power on the bottom. Now I could change the position of this piece by bringing it to the top and making the exponent positive. So I have 4 times 1, and then I have y to the 3rd power now. Now often students mix this up. Since they switch the position of this, they'll take this here and bring it to the bottom. This you don't touch, okay? You're only changing the position of this piece with the negative exponent. So I have 4 times 1, which is 4, and then I have y to the 3rd. Okay, and that's all there is to it. All right, here you have a bunch of properties once again. You have the product of powers property, quotient of powers property, power of a power property. All right, look over those examples, get familiar with the ideas, and let's work out some examples now. All right, so here I have 3 to the 2nd times 3 to the 6th. Since the bases are the same, I take the powers and I add them. So I get 3 to the 8th. All right, for the next one, here I'm dividing these. I have the same base, -4 for both, so I take the powers, and in this case, I subtract them. So I get -4 to the -5 power. All right, I only want positive exponents. So this is in the numerator position right now. I'm going to put it in the denominator position. So there's always a 1 on top then. All right, now make sure you have -4 there because that doesn't change. Only the sign of the power changes. All right, then I have 1 over, and -4 to the 5th power is -1024. All right, done with that. On to C. All right, so here I have a power to a power. All right, when you have that case, you multiply them. So it's z, and I have 4 times -3. So z to the -12th power. And then I rewrite this to make the power positive. I put it in the denominator position. I'm just putting a horizontal line through the z so people don't confuse it with a 2. All right, and that's all we could do for that. Let's go on to the next example. All right, power of a product property. All right, get familiar with that example. Power of a quotient property. Get familiar with that example. All right, let's apply our properties now. Simplify each expression. Write your answer using only positive exponents. All right, so here I have this quantity, -1.5, and then I have y. All right, essentially, I have this, -1.5 to the 1st power times y to the 1st power. I'm just being really clear with what actually exists there. If there's no power, there's always a 1 there. So now, since this is a product here, I'm multiplying these pieces. I can multiply the exponents by the power on the outside. So I end up with negative 1.5 to the second power, and then I have y to the second power. Now, negative 1.5 times negative 1.5 is 2.25. And then I have y to the second. That's all there is for that. All right, for part B now, these are both to the first power, these quantities. So let me rewrite this out so it's absolutely clear what's going on here. All right, so I have a quotient to a power. I'm applying the power property of a quotient. So I can multiply these, and I get a to the third, and then I get negative 10 to the third power. So I end up with a to the third, and negative 10 times negative 10 times negative 10 is negative 1,000. So we always put that negative next to the division sign, though. All right, and we have that. Okay, for C, same deal here as before. That's 3 to the first. Often students forget to apply the power to the 3. D to the first, 2 to the first. Then I have this 4 on the outside. So it's a quotient, and then I have this power on the outside here. I multiply all of these by 4. So I have 3 to the fourth, d to the fourth, and 2 to the fourth. Simplifying that, I get 81 d to the fourth over, I believe that is 16. That's all there is to that. All right, next one, same deal as before. To the first, x to the first, 3 to the first, negative 5 on the outside. All right, so I have this whole quotient here. Applying the power property of quotients. Going to multiply all these by negative 5. So I have 2 to the negative 5, x to the negative 5, and 3 to the negative 5. All right, now let's switch the positions of everything that has a negative power or exponent. So I'm going to have 3 to the fifth on top, and then I'll have 2 to the fifth on the bottom, and x to the fifth as well. So I have 3 to the fifth, which is 243, over 2 to the fifth, which is 32, and then I have x to the fifth. And we can't simplify that any further. Done. All right, so it says, which of the expressions shown represent the volume of a cylinder? Well, here's the volume of a cylinder formula. It's pi r squared times h, okay? Now, what's the radius for the cylinder? Right here, h over 2. So we'll just plug that in for r. And we just keep the h because we don't know what h is. So I end up with pi over, then I have h squared over 2 squared times h. And then I end up with pi h cubed, because that's a 1 there, so I'm adding these two. And then all over 4, because 2 squared is 4. All right, so that's my volume. Now I just have to look at these expressions and see which ones are equivalent to what I have here. All right, let's see. Well, this would be one of them. That's pretty straightforward. Okay, there's nothing we could do to simplify this one, so that's definitely out. There's nothing we could do to simplify this one, and it doesn't match up. That one's out. This one here, no, that one's out. How about this one here? It has negative exponents. So let me take that one. Let's see, I'll do some work on the side here. I have pi h cubed 2 to the negative 2 power. Okay, since that has a negative power, I could bring it to the denominator position. And then simplifying it, I get the volume of this cylinder. So this is an answer. All right, let's do one more. I have pi h, and I have 4 to the negative first power. Take that, put that in the denominator position. 4 to the first. All right, so, and that one doesn't work. You know, but one thing I just realized here, let's check this out. Use my erase tool here. Is that shows an R there? I thought it showed H. So let's go back and work with this right now. That's 2 pi. Let's replace R with H over 2 squared. Oh, R is cubed though, so I have cubed there. All right, so I have 2 pi, and then I have H cubed over 2 cubed. All right, so I end up with 2 pi H cubed over 8. It cancels out, and I get 4 on the bottom here. So that one works as well. All right, so that's another answer. 2 pi r cubed. All right, these are all representations of the volume of the cylinder. All right, going on to the last example. All right, jellyfish emits about 1.25 times 10 to the 8 particles of light, or photons, in 6.25 times 10 to the negative 4 seconds. How many photons does the jellyfish emit each second? Okay, interesting. So we have 1.25 times 10 to the 8, you could say photons, over 6.25 times 10 to the negative 4 seconds. All right, so this is photons per this amount of seconds. All right, they want to know per 1 second, though. So I'm going to have to simplify this ratio here. So I have 1.25 over 6.25, and I could separate the powers with base 10. All right, there we go. All right, and from this, I could apply the quotient rule, quotient property, and this I could just simplify. This is 0.2. 1.25 divided by 6.25 is 0.2. Now I have times 10 to the 8 minus negative 4 power, which is 0.2 times 10 to the 12th power. And it says, write your answer in standard form and scientific notation. Okay, so we're almost at scientific notation here, but I need a number between 1 and 9.9. So I shift this decimal over once. So I end up with 2. All right, and when I do that, I'm essentially taking away a multiplication of 10. So I get 10 to the 11th power. All right, so there's my scientific notation. And then if I want to write it out in standard form, then I just go 2.0, and I move to the right 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And fill in zeros. Whoa. So and then put my commas. All right, that is a big number. That's 200 billion photons. That's a lot of photons. All right, that's all there is to it. This was scientific notation. This is standard form. All right, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.